Hi guys, it's time for chapter 20. It's a longer chapter, so it might really fill in our time here quite considerably, but we'll see how we go. So, human evolution and interventions. This is the basis of our last sack as well. So, humans are primates. We're hominids. Where do we come from? Where are we going to? So, we are primates. Primates are a large order of animals, including lemurs, lorises, New World monkeys, Old World monkeys, huge group. But we share a number of things. Nice small bicuspid teeth, little short nose, well-developed eyes, and of course these large brains, and grasping hands. Not necessarily a opposable thumb, but often that's the case too. But certainly the ability to hold on to things and start to use tools and weapons. We belong to the group that are more commonly known as the hominids, so the family Hominidae, which includes gorillas, orangutan, chimpanzees, and bonobos. We have no tail. We have a relatively large body size in comparison to other monkeys. We're complex. We have a complex cerebral cortex. We have that characteristic upper jaw and frontal bones of the skull. And of course that opposable thumb that we start to see tool using in all the hominids. There is considerable molecular evidence for this. So the DNA sequences of the mitochondrial DNA of humans and apes have all been completed. In fact, we've now got the DNA sequences of our own nuclear DNA for humans and all the major apes. And they show an amazing amount of similarity and lead us to seeing how we can produce a phylogenetic tree to show our relationship. So essentially the belief is that the orangutans diverged from a common ancestor first. Then a bit further along, the apes diverged from a common ancestor, and then we diverged from a common ancestor with the chimps, and chimps branched again into chimps and bonobos. And it's all quite provable from the DNA at mitochondrial and nuclear level. So, us, Homo sapiens, we belong to the superkingdom Eukarya. We have eukaryotic cells. We are an animal, kingdom Animalia, with a chordate, with a notochord running down our spines, so phylum Chordata. We belong, of course, to the class Mammalia, subclass Theria, so it's the eutherian or placental mammals. The order of the primates, family Homidae, we're in the genus Homo, the only extant species in the genus Homo, and we are often described as Homo sapien, the modern sapien. How are we different to other primates? Well, we walk upright. As we saw in Don Johansson's film, we've got that knee structure that allows us to do that more efficiently. We have fewer teeth and they're smaller. Our faces are flat and lack heavy brow ridges. Our cranial capacity is quite large. We're extremely good tool makers. We have great use of language and art, and that often provocative one, we are self-aware. How self-aware are other animals? Well, lots of conversation on that one, so we won't go there right now. We will be aware of the new discovery recently of more remains of our ancestors, and they may well be after this particular discovery and before Lucy, by the look of things. So we have 4 recognised genera of hominids. There are many different systems for this. The Sahelanthropus occurred about 6 or 7 million years ago. Very ape-like brains, short faces, and much more human-like teeth than the apes. And you see that wonderful brow ridge. In the next group, of course, are the Australopithecines. So this is Lucy's mob. So 2.5 to 4 million years ago, fully bipedal, human-like hands, but chimp-like brain, large face, but human-like teeth. And we certainly have 3 species described: Anamensis, Afarensis, and Garii. Lucy, of course, was a member of the Afarensis. After that, they branch into what were known as the robusts and the gracile. So the Paranthropus were very similar to Australopithecines, but they started to use tools. Now, we don't know if Australopithecines did or didn't, but we certainly find tools in the fossil beds with the Paranthropus. And we have the Robustus, Boisei, and Aethiopus. So there's 3 species here, all of course now extinct. And then arise Homo sapien, or Homo genus. At the moment, that new discovery has been placed in the Homo genus, which is interesting. one extant species and a growing number of extinct. We've got 8 here, but I think there's more now. So Homo rudolfensis, the earliest species dated from fossils found at Otterville Gorge and Lake Turkana. So the same place we find Australopithecines. Small brain capacity. And then habilis, with a relatively primitive species of small brain capacity. Then we get Augusta and Erectus. So Augusta is essentially the African version of Erectus. There's some, quite a lot of conversation around these things. But we're starting to see much better skull structure, showing much bigger brains. And interesting enough, the larynx structure is showing that we now have the ability to make speech, not just grunts and groans, but words, which defines us from all the other animals, of course. Then more recently, we have Heidelbergensis, which is only known from one single jawbone, so who knows what the hell that is really, and Neanderthals, the Neanderthalensis, which survived with us. 30,000 years ago they disappeared, and were certainly around when we were around. They had slightly larger brains than we did, certainly heavier brow ridges, less developed chins, and very elaborate cultural displays. There was a time when we believed that they weren't interbred with humans, with Homo sapiens, but the belief now is that they were, in fact, we have Neanderthal genes in our own Homo sapien genes, so look like we interbred. In recent times, we've discovered Homo floresiensis on the island of Flores, which was interesting because it goes backwards. It's a dwarf species, small brain size, but all the other characteristics are quite modern. And they appear to have become extinct only 18,000 years ago. So they were there on Flores when Aborigines were on Australia. Since then, of course, we've discovered the red deer cave people of China, the Denisovans throughout Asia, Siberia, Europe, and this recent discovery in South Africa of, I forgot what they're calling it now. So there's a number of species of Homo that seem to be coexisting, and Homo sapiens seem to have won out. So Homo sapiens, our modern hominids, the only last extant species, show flat face, an erect posture, big brain size, loss of tool use, use of fire, use of ceremonies, and use of symbols. There are two main theories for how we arose and where we arose from. The one which is preferred is called out of Africa, and it suggests that Homo Augusta or Erectus arose in Africa and then walked out into the rest of the world. And then Homo sapiens did the same thing, arising in the Rift Valley and again going out to take over the whole world. The evidence for this is the concentration of fossils of similar age in the Rift Valley and patterns of analysis of mitochondrial DNA. So you'll see on this map here, the blue and yellow lines show the movement of human mitochondrial DNA. So you'll see the M173, M17, not highways, but rather mitochondrial maps across the globe. And you've got Adam and Eve there in the Rift Valley, just for a bit of fun. Alan Thorne, the great Australian paleontologist who died recently, based at ANU and discovered Mungo Man, was a great proponent of parallel evolution, or the idea of regional continuity. He suggested Homo erectus, migrated out of Africa about a million years ago, and then independently evolved in Homo sapiens at various locations around the globe. All these new discoveries of new species that were extant with us is suggesting he may well be correct. So while the populations were geographically isolated, there was some contact and there's some gene flow between them, so hybridization created one larger gene pool. So we find Erectus in Asia, just as old as the African Erectus. Floresiensis is seen as a Sepoin's theory, and there are a number of other species of Erectus and Homo sapiens around the planet, which would suggest that there's maybe some time in this, but certainly not the favoured description. And we see that him using similar sort of data showing the movement of DNA across the planet. So we see the movement in the yellow there, my mouse here, here of Homo erectus, and then these orange ones are later movements of indigenous peoples from these locations here. So here's Mungo Man, Alan Thorne discovered down near Bathurst, about Broken Hill. Been there about 60,000 years. Goes back a fair way into this area here. So it's an interesting idea. We'll soon find out. Well, maybe we never will. How long have humans been on the Australian continent and where they come from? Well, we certainly came from Asia, and they were able to do that because the water between islands is much lower than it is now, and in fact they could have walked some of the way. The most recent ice age is 11,000 years ago, so certainly some came at that time. The one before that was 150,000 years ago, but human remains and other things like cave paintings and middens and footprints in locations are pushing them back further and further all the time. And some people are suggesting they've been here 100,000 years, which would mean they were able to cross that water fairly successfully after the second last ice age, which is interesting in itself. Don't know why I put that slide in, but there you go. So there's these, the island chain there. So they've been able to work their way reasonably easily through mainland Asia, and across this island chain here, which we now call Indonesia, which with lower water levels would have been much easier to do. And that small gap from East Timor to Australia would not have been too great at all. Now your last sack is really about how humans now intervene in evolution. So we've always changed our environment to suit ourselves, and this affects the course of our evolution. So we settled and we became agricultural people. We started domesticating animals and plants and selectively breeding them for our purposes. We now, of course, use modern genetic techniques to do the same thing. And this tends to put us outside of evolution in the fact that we influence the manner in which we could evolve. We'll be looking at how wheat and humans have caused the change in evolution in the two species. So, I made it. 12 minutes. That's going to be a long one, that one. We'll talk more in class when we get a chance. And now I'm going to work out how to turn off again.